Kia ora, hello, namaste, ni hao. This is Prashant, and we shall be continuing with our Fortinet series of labs and discussions. This video has been created for you to understand the theory and the fundamentals of FortiGate Diagnostics and how to use the features available in a FortiGate to diagnose a system. This is Lab 9 in the FortiGate Infrastructure Guide Operating System 6.2 version series, and the details of this lab are mentioned on page number 136 till 142 in the Infrastructure Lab Guide. This video will cover the general diagnosis processes used within a FortiGate and also make you understand what debug flow means. The virtual machines you will need for this lab are Linux, FortiGate Manager, a local FortiGate, and the local Windows. If you watch this video and read through the guide, it should take you approximately 25 minutes to complete the lab on your machines. For those who are using the virtual system, it is essential that prior to starting the lab, they should restore the original file to local FortiGate firewall from the folder on local Windows VM desktop. It's present at the folder resources initial lab environment -config and upload the file local-initial.config. This file will reset all firewall conditions, and you should not have a problem in the network if you configure the details as per instructions. While doing the lab, the local FortiGate config files are located in the resources, infrastructure, diagnostics folder as mentioned in the lab guide. Now, after completing this section, you should be able to achieve the objectives shown on the slide. Basically, you should be able to identify a network's normal behavior or make a benchmark, monitor for abnormal behavior such as traffic spikes, and then diagnose the problem at the physical and the network layer. Now, we had discussed what a baseline is in one of our labs in week number 4. However, let's now look at what is a baseline from a graphical perspective. In order to define any problem, first you must know what your network's normal behavior is. This normal behavior is called the baseline behavior of a network. In the graph shown on the slide, the range that indicates normal is shown in blue. If you look at the right side, what exactly is this blue line? It indicates the averages. That means the network baseline. Now, what is the thick black line? That denotes the current behavior. When the current behavior leaves the normal range, an abnormal event is happening. Normal is measured in many ways. It can be based on performance. That means the expected CPU and memory utilization, bandwidth consumed, and the traffic volumes. But it can also be your network topology, which means which devices are connected at each node. It could also be behavior within your network, which means where is the traffic flow direction, which protocols are blocked or proxied, and the distribution of protocols and applications used during specific times of the day, week, or the year. Now, how do we define what is normal for our network? Flows and other specifications of normal behavior are derived from topology. So during a troubleshooting session, a network diagram is essential. If you create a ticket with Fortinet technical support or even for ITS, a network diagram should be your first thing you attach. Network diagrams sometimes combine the two types of diagram. That is, one, a physical diagram, two, a logical diagram. A physical diagram shows how cables, ports, and devices are connected between buildings and cabinets. A logical diagram shows relationship, usually at the OSI layer 3, between virtual LANs, IP subnets, and routers. It can also show application protocols such as HTTP or DHCP. Another way to define normal is to know the average performance range. On an ongoing basis, collect data that shows normal usage. For example, if traffic processing is suddenly slow and your FortiGate CPU use is 75%, what does that indicate? If the CPU usage is normally between 60 to 69%, and then 75% is probably still normal. But if normal is 12 to 15%, there may be a problem. So if you look at what the that particular abnormal activity is shown on the graph here, you realize what I'm trying to convey to you. Now get data on both typical maximum and minimum for the time and date. That is on a workday or a holiday. How many bits per second should ingress or egress on each interface in your network diagram look like? So you could probably have a closer look at how things are moving in your network and decide what would be normal and what could lead to a complaint. Some of the tools available within your system and your dashboard are the Security Fabric widget, FortiView, SNMP. You could also create an alert email that can send back messages as soon as there's a spike. You could log into a syslog or FortiAnalyzer and see what's happening. And there are certain CLI debug commands that can also assist you in knowing what had happened in the past. Now a quick look at how can you get information about the current status. Now, first, let's look at the CLI commands you can use. You can use them either through the local console, even if network issues make GUI access slow or impossible. A few commands provide system statuses. The get system status, as mentioned on the slide here, command provides most general purpose information. The output shows model, the serial number. You could also get the firmware version, the FortiGate license statuses that is given around here. All the license status is given here. The host name, whichever device you are actually using at the moment. What is the operating mode, the version of the FortiGuard, antivirus, IPS, what exact version are you using here? All that can be visible here. Now at the physical layer, troubleshooting analyzes which ports are plugged in, what is the media capacity, and negotiated speeds and duplex mode. Now, if you quickly have a look at these columns, you will realize that this is visible here when you get the hardware, get hardware NIC and the interface name command at the CLI. At the data link layer, Diagnostics often analyzes how many frames are being dropped. So if you see the transfer packet, what are the number of frames that have been dropped, etc., can all be mentioned here. The output might vary depending on the model and the NIC driver version. In all the cases, the output shows the physical MAC address, the administrative status, and the link status. If you suspect that there is an IP address conflict or that an IP has been assigned to the wrong device, you may need to look at the ARP table. The get system ARP command is used for that purpose. It shows the FortiGate interface, the IP, and the hardware address, including the interfaces there. This command lists all information for all external devices connected to the same LAN segment where FortiGate is connected. FortiGate's own IP and MAC address are not included. Now let's have a little bit of a look at the network layer troubleshooting, which is important. Now say that the FortiGate can contact some host through port 1, but not others. Is the problem in the physical layer or the link layer? Neither. Connectivity has been proven with at least part of the network. Instead, you should check the network layer. To test this, as usual, start with the ping and trace route. The same command exists for IP version 6. Execute ping becomes execute ping 6, for example. Remember, location matters. Now, test will be accurate only if you use the same path as the traffic you are troubleshooting. To test from FortiGate to maybe a FortiAnalyzer or a FortiGuard, for example, use FortiGate's own execute ping and execute trace route CLI commands. But to test the path through FortiGate, also use ping and trace route or trace route from the endpoint, that is from the Windows, Linux or Mac OS computer, not only from the FortiGate CLI. Because of NAT and routing, you may need to specify a different ping source IP address. That is, the default address is the IP of the outgoing interface. If there is no response, verify that the target is configured to reply to ICMP echo request. So time for a quick knowledge check. Question number 1, which CLI command can be used to determine the MAC address of a FortiGate's default address? A, get system ARP, B, get hardware NIC. Question 2, which CLI command can be used to diagnose a physical layer problem? A, execute trace route, B, get hardware nick. So get your answers and make sure that they come up on our chat. Now let's now learn, after having understood what general diagnosis is, let's just quickly go on to what debug flow is from a FortiGate point of view. In this part of the video, we shall diagnose connectivity problems using the debug flow utility. So what is debug flow? Now, if FortiGate is dropping packets, can a packet capture sniffer be used to identify the reasons? To find the cause, you should use the debug packet flow. Now, the debug flow shows step by step how the CPU is handling each packet. To use debug flow, you need to follow these steps. First, you need to define a filter. You could do that using the command diagnose debug flow filter and define the filter. Enable debug output, that is diagnose debug enable. Start the trace. In order to start the trace, you could use the diagnose debug flow trace start number of packets, or whichever you want to trace. And stop the trace, you can diagnose debug flow trace stop. We shall be using these as the lab proceeds. We'll now show an example of debug flow output which captures the first packet of a TCP three-way handshake, the sync packet. It shows 1. The packet arriving to FortiGate indicating the source and destination IP addresses, port number, and the incoming interface. Then the FortiGate creating a session indicating the session ID. Then it shows the route to the destination indicating the next hop IP address and outgoing interface. It is followed by the ID of the policy that matches and allows this traffic to come in. And finally, how the source NAT is applied. Now this slide shows the output from the sync ACK packet. It shows the packet arrival, indicating again the source and destination IP addresses, port number, and incoming interface. Next, it shows the ID of the existing traffic session for that particular traffic. The number matches the ID of the session created during the sync packet. Third, it shows you what the destination NAT is applied and how the destination NAT is applied. Finally, it shows the route to the destination indicating the next hop IP address and the outgoing interface. If the packet is dropped by FortiGate, this debug shows the reason for that action. This tool is useful for many other troubleshooting cases, including when you need to understand why a packet is taking a specific route or why a specific NAT IP is being applied. Coming on to our final knowledge check, 2 questions. 1. What information is displayed in the output of a debug flow? A. Incoming interface and matching firewall policy. B. Matching security profile and traffic logs. Question 2. When a new TCP session is allocated, when a sync packet is allowed or when a sync ACK packet is allowed. Keep your answers flowing, and we shall then get on to the next step in our class today.